Hello, welcome to Ekidel. We are trained for civil and structural engineering. My name is Justice Monoka and I am your instructor. Today, I'll be showing you the part 12 of this 16-story building design using ProtaStructure. So right now on this our project of designing a 16-story building, as you can see there, we have designed from the part 1 up to this very part 12. So if you're new on Ekidel, I would say that you can quickly subscribe to our channel and give this video a thumbs up, and also click on the bell notification so that you will be notified whenever we post a new video. Okay, so right now on this 16-story building, I'll be showing you now the part 12, and on this part 12, the next thing I'm doing is to load the wall of this swimming pool. So looking at this right now, you can see that on the part 11, we modeled this swimming pool. So if you have missed that video, you can check that directly on the part 11. So on this part 12, I'll be loading this swimming pool, and on the part 13 will now be the structural analysis and design. All right. So right now, to load your swimming pool wall, because on the part 11 we loaded this floor of the swimming pool, and we didn't load the walls of the swimming pool. So on this part 12 now, I'll be showing you how to load the walls of the swimming pool now. So to load the walls of your swimming pool, so what you have to do is to click on one of the walls, and once you click on one of the walls, then right click, and then you will see what? Edit loads. All right, so you have to click on edit loads. Now if you are using any other lower version of ProtaStructure of software, what you will see is wall load. So right now, if you're using this new version, you have to click on this place that says edit loads. Now on this edit load now, it will show you this interface of load editor. Now on this load editor now, I will have to come to this place here that says wall area load. Now there are two ways you have to load a retaining wall. The first way is to use either the soil load, and the other way is to use the wall area load. Now if you're using the soil load here, the soil load here looks more complicated for beginners, and the reason why I say that it looks more difficult for beginners is because you have to define everything here by yourself. So it's like you inputting everything by yourself. Why on this area load is basically, like as you can see, what we are trying to factor into consideration is the weight of the water from the pool that is going to act on this wall. So because of that, we are going to use wall area load, and also knowing that there is no soil at the back of our wall here, which is trying to now cause act another pressure at the back of this wall. So since there is no soil at this place, I am not going to use this soil load, this soil load area to now apply my load on the wall. Although I can still use this. So what I will just quickly do is to go and remove the soils from the wall. Like now, if I say I want to use this place now to now apply my load on this place, I will click on this place right now and then click on this wall here. I will now see this add soil load parameter. Now since there is no soil at the back of the place, I will just quickly come here first and delete my soil layer. You can see that the soil is off, and I'll come here and delete my surcharge. There is no surcharge coefficient. I'll just delete that off and all that. And then, although there are different steps that you are meant to take up into consideration here, so because of that, I will not want to go through this route or through this process. So I will have to use the simplest one, which can be very, very understood by anybody at all. So I'm going to use this surface area. So since I'm using this surface area right now, I'll have to start this all over so that you can be able to follow up the process. So right now, I'll just quickly say cancel here. Now to add your wall load, on your retaining wall for this pool, I'll have to click on this place now. Since there is no soil at the back of any of the pool here, because this is like a rooftop swimming pool, so we are not having any other counter force at the back of the wall. So right now, I'll have to click on the wall, right click here, and then come here and then say edit loads. Now on this edit loads now, I will now have to come here and then click on my wall area load. Now on this wall area load now, I have to, once I click on the wall area load icon, I'll have to now come here and then click on this icon of my wall here, and I'll try to rotate this right now. You can see that your walls are already displayed, having a load of 1.0 kN per meter square. Now on our previous video, which is the part 11, we have already calculated the load of the water. Okay, and we got our load of the water to be what? To be 13.63, if you can still remember. Okay, and also 13.63 as the load of the water. Okay, so if you want to get this load, or what you just do is to get the area of the pool and then multiply by what? By the density of water times the height. Or you just, or in a very smart way, you can use the height of the pool multiplied by the density of water. But basically, we considered, we factored many things into consideration, because this is not really an infinity pool, so the water is not full to the brim, so we have to remove at least 170 millimeter off from the height of the pool, and then we now use the remaining 1.3 something meters to now calculate for the load. Okay, and that was how we now arrived to this 13.63. okay, so right now, once you have inputted your value for the magnitude 1 and magnitude 2, and then for this place that says measurement types, I would say that you should leave it at percentage, because if you leave it at distance, what it means is that you know where the water will stop and all that. Now I want to leave it as percentage, because I want it to I want the load to be taken off by to be loaded by the full wall. Okay, so right now I'll leave it as percentage, and then once I do that right now, I will now come here and then click on update. Now on this, once I click on this update, now you see that all this load data shown 1.0 or 1 kN per meter will now change towards 13.63. So I'll come here right now and then click on this update, and then you will just see them change right now. Okay, so you can see that all our load now have now changed to 13 point this. Now what this means is that what is acting on the surface of this wall is 13.63 kilonewton per meter square load, and it's being acted on this retaining wall. So once I do that right now, I will now come here and then click on what? Okay. So once I click on OK now most of the times you can see that when we are inserting wall load, we go ahead, once we have added one of the load, we'll just go ahead and then copy the load and onto every other one. But in the case of a retaining wall, you don't have to copy, you must have to define the load on each of the walls. Okay, so right now I'll come here again right now and then click here and right click again and then click on edit loads here. Now if maybe you missed the other parts, or let me say you didn't capture what we did before, so since I'm going to repeat the same thing I did before, you just have to catch it up here right now. So I'll come again right now, click on the area load here, and then click on the wall icon here, and then you will see your load, surface area load will just display here. Now on this area load now, I will have to come here and then specify my load, which is what? 13.63 as calculated. This is not a default value for design, but for this particular design of this system building and for this pool, this is the load this is the load of water that we have. Okay, and I'll come here and then click on what? Update here, and it will change. I'll come here and then click on what? Okay. Okay, so why I just repeat what we are going to do and then float all other walls here. I'll just tell you that if you want to know more about structural design, I will say that you can enroll for our Ekidel mentorship class, either for structural design or for structural detailing. So if maybe you are interested to know more about Ekidel, to know more about design of structures and also detailing, you can enroll on any of that, either for detailing or for design. Okay, and then we will have to train you on that, especially using either Google Meet or Microsoft Teams or Zoom app, and train you using the live screen and all that. And then you have, okay, so right now I'm going to put this right now 13.63, and also here again right now 13.63. Okay, so 63, that's fine. And I'll click on what here, update, and then I'll click on what? Okay here. Okay. Okay, and also if you have any question about all the parts that we have done for this system story building, and if you're following this system story building, you can ask your question if anywhere you are having issues. And also we have a WhatsApp platform. We have an Ekidel global WhatsApp platform where all engineers interact and ask questions based on where you're having difficulties, if maybe you're performing a design. So if you want to be among the Ekidel WhatsApp group, just check on the link down below, and then click on the link, and then you'll be approved and then be added to the group, so that you can also interact with fellow engineers and all that. Okay, all around the world. Okay, and I'll come again right now and put 13.63. that's fine, and I'll say update here. Okay, and I'll come here and then say okay and all that. Okay, and then I'll have to say okay first. Okay, I've done all the okay that. And I'll come again right now, rotate again, and then apply my loading. Now, this load is only applicable on on the retaining wall around the pool. As you can see that we also have retaining wall for the lift. So don't apply the load on the lift, only apply the load on the wall. Now, if you want to follow up for this 16-story building, there is a link to the cat file of this 16-story building. So you can quickly get a cat file of this 16-story building and then follow us up for what we are doing on this 16-story building, because this is the number one high-rise building that we are going to complete up to pipe foundation, and we are currently on the part 12, as you can see that. And I think the next stage right now we are moving into part 13 is for the structural analysis, which we are almost going to be done, and the part 14 to 15 and 16 will be on foundation design and all that. So this is, you can see the reason why you made the follow up. Now the cat file is not free, so it is not free. So if you want to get this knowledge, you can quickly get the cat file and then purchase the cat file and then follow us up. Or if you want to use a different drawing altogether, it is fine, but just follow up what we are doing. But it is better for you to use the exact cat file that we are using, so that you can be able to follow us up on everything and catch up everything together. Okay, so right now we have to also come here and add up for this other one. So we are almost done with adding the load here. I'll come again right now and click on edit load here. And then I'll click on this surface, this wall area load here, and I'll click on the wall here, and I'll come here and add my load 13.63, and I'll come again here right now 13.63. Sorry, that's not that bad. Sorry. Okay, let me just undo everything here. 13.63, that's fine. And I'll come here and click on what update here. Okay, and I'll go again right now and then say okay here. And we are almost done, remaining just 2 walls that we are left to insert our to define our load. And I'll come again right here, click on this place here, right click here, and then edit load. Okay, that's fine. Now come again right now, click on wall load here, sorry, wall area load here, click on this and then come here and define 13.63, and also the same thing here, 13.63. So whenever you are doing your design, make sure you are careful when you are inputting your loads and all that. And note that most of the values that we use on Ekidel here are not constant, except for some values like the dead load for residential buildings and all that. Those ones are factored and all that. But most of the values that we use here are not constant to be used on every structure. So we use load based on the particular structure we are designing for. That is why we use real life projects to teach here on Ekidel, so that you can be able to see how the loads are being applied on real life. Because if we just pick up and then begin to use all the icons here and do that, you won't be able to appreciate you won't be able to appreciate design. Okay, so whenever you are trying to share knowledge to anyone, I would say that you should do what is applicable on during construction and also in real life practice. Okay, so I'll come here and then click here and then come here and do this. Now the best thing you can do for anyone right now, either for your colleagues or for your friends as a student, is to share our videos to your friends and colleagues, so that they will also know what is happening here at Ekidel. The mission of Ekidel is to make sure that we make civil engineering simpler and to share knowledge generally. That is why we created a WhatsApp group platform, so that every engineer can be able to share their knowledge around the globe. Okay, so right now you can see that we have applied all the loads for the retaining wall and all that. And if you hover your mouse on any of the retaining wall, you can see that there is a place there. As you can see, this directly that says area load there that is showing 13.36. So that's the area load on the wall, as you can see also. Now, had it been this pool was not elevated, let me say this pool was directly on the soil, and then we have soil load also at the back of this place. That is like a counter force from the soil. So we would have used the place that says soil load. Okay, so let me see, whenever we are doing that kind of design, I will show you when to use that kind of area, that kind of area load and all that. Okay, so right now you cannot see how we have just applied all our load and all that. Now let me just take a glance of everything that is done on this 16-story building from the part 1 for the people that are just coming new. So we started this 16-story building from the cat file where we did our structural framing or the GA drawing, where we have to position our columns and frame the structure, did our paneling, and also arrange how our beams are going to run. And then we now imported that cat file, which is the DSF file, into the software here and begin to model our structure. And we modeled the first and story, the the first story, second story as a solid slab, as you can see that, and then we now use a waffle slab from the third floor down to the 16th floor here. Now the reason for using a waffle slab was to reduce load. So that was on the part 9 and 10 where we did about load reduction, because when you are designing for a high-rise building, you are meant to try to reduce the load of the structure. Okay, so we use waffle slab to also reduce the weight of the structure, and then we also applied life load reduction method based on percentage, based on the story. So we have done many things about that, and then we now modeled for this pool top here at the top here. We have modeled a swimming pool at the part 11. So on this part 12, you have seen how we have just applied or defined the weight, like the effect of water on these walls. Okay, you can see that we have defined a water load of 13.63, which is the pool water load, 13.63 on this wall, on this pool wall here. Okay, so right now on the part 13, we are going to be entering into the structural analysis, because right from the very stage we have already defined wind load and also thermal load for this structure. So if maybe you have missed that, I would say you should watch the previous videos and all that. So we are entering the structural analysis from part 13 of this video series, and then after that, right now, we will now enter into what they call interactive design, to see the members which are not sufficient, and then increase the size of the members and all that. Okay, so thank you so much and God bless you. Now, if you are new on Ekidel, once again, I will say thank you to Ekidel. My name is Justice Onwaka, and I'm welcoming you to Ekidel. And the only thing you have to do is to subscribe to our channel and then turn on your video notification. And also, if you are an old subscriber and you have not turned on your video notification, I would say that's a very bad idea to do. I would say you should just do that right now, and also give this video a thumbs up and share this video to your friends and colleagues. So thank you so much and God bless you, and see you again on the part 13 of this video series, which is the design of single building, which will now be on the structural analysis and design. So thank you so much and God bless you. Love you. Goodbye and bye for now.